So guys, let's get into it. We're going to have a look at arithmetic sequences today. So this is stuff you've been doing like since grade 8, but we build on it. So it's really important that we do know this stuff. So can anyone tell me anything about arithmetic or linear number patterns? Is there any information you know that defines them, that's unique to them, anything like that? Nice, Josh. Excellent. So exactly, there is a constant first difference. If you just say constant difference, or that's how you think of it, that's fine as well. Oh, and then I don't write first. This has been the Wednesdayest Wednesday ever. Right, this is our defining characteristic of a linear sequence or a linear pattern. Now, guys, obviously, as the name suggests, they are linear, which means that this constant difference, if we were to graph this relationship, it would be a straight line, either increasing or decreasing. It depends on what the difference is. Now, you don't need to be able to draw graphs in the section, but it is really important that you are able to make the connections when it comes to algebra and linear equations, when it comes to functions and patterns, because there are so many ways to represent these relationships, graphs being one of them, a formula like a pattern being another. So it's important we start to make those links so that we're comfortable with with what's going on. Now, much like I said on Monday in terms of quadratic patterns having a constant second difference, knowing that linear or arithmetic patterns have a constant first difference is super important. We're going to use that characteristic in slightly more complex questions to deal with solving of unknowns or dealing with, like I say, harder questions or problem-solving types of questions. Knowing that characteristic is really important. Okay, but let's start off slow. Let's have a look at an example together, and then same as Monday, I'm going to give you some that you're going to try by yourself as we go along and as we talk about things. So here, excuse me, here we have got an arithmetic sequence 5, 12, 19. I'm just going to write it here so we can look at what's going on. Remember, I've said to you as well, if we don't tell you it's arithmetic or quadratic or whatever, you will need to determine what type of sequence it is. But honestly, guys, most of the time they will say, given the quadratic or consider the arithmetic, you will know exactly what you're working with. So because I know it's arithmetic, I should know, or I should expect there to be a constant first difference. So if we go and have a look at our pattern, we can see that each time I'm adding 7. And again, I really recommend that you do this, that you just look at your pattern. What am I adding? What am I subtracting? What is the situation going on? Because it's going to help you answer questions later on. So our first question that we need to answer is determine the general term. So we've said the general term is like a rule for the pattern, and we need to now find it. So this is now, this is now an arithmetic sequence. So it's not the same rule or not the same formula that we use as we did with quadratic. It's a bit different. So does anyone know, and there's 9 of you, so you're welcome to just unmute yourself and speak. Does anyone know what the general formula for a linear or arithmetic pattern is? I can never say that word, no matter how hard I try.
Is it Tn is equal to A plus N minus 1 brackets is D?
Awesome, amazing. That is exactly it, guys. We use Tn is equal to A plus N minus 1 times D. End of story. There is another formula that you can use, which I'm going to write down, and I will show you how to work with it. I know some teachers don't like you using it. I'm not really sure why, because I actually find it a little easier personally. But yeah, both of them are right. Both of them will get you marks in finals. If your teacher has like specifically told you you're not allowed to use it for whatever reason, then just ignore it. Excuse me. But I do think it's a little easier. That's just my personal opinion. Both of them work. You decide what works best for you, and that's what you use. So I'm going to start with the sort of orange one first, just because that's the one probably most of us know and have learned, which asks us for a bunch of different values that we need to substitute in. Now, I don't want to say obviously, but I think it makes the most sense to start with D, because that would be our constant difference. So we would need to know what D is in our general formula. Does anyone know what A represents? What does A represent in this formula?
A represents the first number.
Okay, cool. So A is the first term of your pattern. So in this case, it would be 5. I do see that some of you are unmuting multiple times, which is awesome. I love it. So maybe let's do raise your hand, and then I can pick someone just so that we don't conflict. But yes, exactly. A is our first term, and then just a reminder, Tn is the value of your term. So spell. So for example, if you wanted the value of term 3, we know that's 19. So it's the value of your term, whereas n is the position of your term. So the first term, the second term, the 75th term, etc., etc. So when we go and use this formula, all we need to do is we need to substitute. So Tn is equal to, A is 5 in this case, plus n minus 1 times my difference, which we've worked out, which is why I say always go and figure out what's going on, times 7. Now, grade 12, what's really important is that you know that even though we've always told you, and I will maintain this till the end of time, we've always told you to simplify. You should always simplify your answers. And I'm going to simplify this because I feel strongly that we should always simplify. However, in finals, if you did not simplify this answer, you will get full marks. And they are not going to penalize you for not simplifying your formula. If you stop here, you will get full marks for it. I feel strongly we should simplify, but that is also just a personal opinion. And so what we need to do is distribute the 7, leaving us with 7n minus 2 as our general formula. All right, so you don't have to simplify. You can if you want to. It's not an absolute must. I prefer to do it. It makes me feel better. Like I said, you're not going to be penalized. Right, so that's the first way that we can do it. Excuse me. I've got a frog. Okay. The second way we can do it is with this formula over here. Tn is equal to dn plus c. Now again, I prefer this. It's a way you probably learned how to do it in grade 8, grade 9 through inspection, for lack of a better word. So we know d is the difference. So Tn is equal to 7n plus c. And if you think back to your straight line formula, y is equal to mx plus c, c is that constant. C is just a value. If you think about it in terms of a straight line, c would be your y-intercept. But essentially what we need to solve for here is c. Now, in order to solve for c, we would need to know the value of n and the value of Tn, which we have. If we take any one of these terms in my sequence, I have Tn, because I've got 5, 12, 19, and I have n, because I know the first, the second, the third. So you can pick any one that you want, and you could substitute in. I'm going to pick term 1 because it makes my substitution easier. 5 is equal to 7 times 1 plus c. And if I then solve for c, c is equal to -2, which means that Tn is equal to 7n minus 2. Now you can also just do this by inspection. So when I say by inspection, I don't want to say by guessing, but you can look at it and you can work it out without needing to set up a formula. And the reason for this is there's a really cool sort of relationship that exists with these values. Our constant difference of 7 is always going to be, always, in a linear pattern, is always going to be the coefficient of n. So if you know what you're adding or subtracting each time, you automatically have your n term. And then you just have to decide, well, what do I add or what do I subtract to get each of my terms? So personally, I quite like by inspection. I quite like just figuring it out, but having the formula there is also useful to just sub in and get your answer. So either one, it's completely up to you, whatever makes you happy. At the end of the day, what your markers are going to mark is not necessarily all the working out. They're going to mark your D, and depending on how you've chosen to do it, the fact that you substituted into the formula correctly, or that you got the correct constant. Because remember, you don't have to simplify. So this is a 2-mark question. And that's why I'm saying there's no need to try and use the formula if you're not comfortable with it. Just do it by inspection. Alrighty, so that's our first question. The second question is asking us to determine the 10th term of the sequence. Now, we know this from our quadratic lesson on Monday. All we need to do here is we need to figure out what variable have I been given. Now, this is a position. So guys, is that Tn or is it n? And remember, let's raise our hands because there are quite a few of you quite keen to answer, which is amazing. I love it. But does anyone want to raise their hand and tell me what variable 10th represents? Or you can just unmute yourselves. No one's raising. So are we going to substitute 10 in, Atila, sorry, I will start talking.
We're going to substitute 10 into n.
Awesome. Remember, position is n. So that is where we put that bad way. Oh, God, Miss Molly. Can you also see my screen? I've just touched something a bit strange. I'm going to assume yes, there's no one shouting, so I think we can all see it. So term 10 is equal to 7 times 10 minus 2. Nice and easy. The 10th term is 68. Right, so that's it. We just sub in, off we go. Kirsten, all right. So I'm going to do my best to explain this to you. There should be a little like bar somewhere on your Zoom interface. And there is a thing, I don't have it because I'm a host, but I think there's a little tab there that says reactions. And then there should be a raise your hand that you can click on. If not, you can also just put in the chat, I've got it open, or you can just unmute yourself. We'll make it work. Cool. Alrighty, guys. So that's it, position. So I want you guys to try for me, or try to answer for me, question C, where I've asked which term has a value of 187. So we did questions like this on Monday with the quadratics, nothing different. So let's see if we can figure out which term has a value of 187 here. While you're doing that, just welcome to everyone who wasn't with us on Monday. It's so glad to have some more faces and some more people with us. So I hope that you enjoy. And obviously, guys, at any point you're stuck, you have questions, you're not sure, just ask. That is my job. That's why I'm here. Once you've got an answer, you're welcome to put it in the chat. Otherwise, I'm going to ask for some answers in a minute or two. It's not a hard one to solve because it's linear, but I will give you a second. Nice. Nice, Kirsten. Fulmian Corsi, nice. Tobazani, nice. And guys, again, if like leaving your answers n equals whatever is perfect. Don't write a sentence of the whatever term has a value of n equals. That's it. Nice, you guys are on it. I'm hoping that means we're going to be able to get some nice fun ones tonight. Okay, so exactly. We're substituting 187 in place of Tn because I'm giving you the value of the term. So 187 is equal to 7n minus 2. And this is a linear equation, guys. So it's not necessarily a complex equation that we need to solve. It is linear, so it's not too tricky. This would be 189 is equal to 7n. And so that divided is what you guys have said there in the chat, 27. So the 27th term has a value of 187. Nice, guys. Very nicely done. Right, so you are going to get two examples here. There's just a little mistake that I need to fix in the easy example. I don't know how many of you are going to do the easy example, but that should say 73, not 74. I do apologize. Right, so those of you on Monday, you know the drill. Those of you that are new, pick one. If you're not feeling super comfortable with arithmetic or linear sequences, do the easy one. If you're feeling awesome, good, I know the stuff, let's get to the hard ones, do the medium one. I'm going to show you both answers, so you can screenshot both and you can go back and practice one or the other. But try one of them. I'm going to give you 5 minutes. Well, I'll check in after 5 minutes, see where you guys are at, and then we'll go from there. And guys, remember, if you've got questions, ask them on the chat or unmute yourself and ask. Again, that's why I'm here. So let me know. And if you don't feel super comfortable asking in front of everyone, you're welcome to direct message me as well. And I'll help. Most of you are trying the medium one. Very nice. Okay, so guys, the link I've just put there in the chat is for the Google Classroom, and that's where you'll also be able to find the recordings. So please make sure you're on there. If you have a problem, again, just message the WhatsApp line and we'll help you. But it is quite nice that then everything is in one spot. When it comes closer to exams as well. Oh, that was a lot of as wells. When it comes closer to exams, I'm also then able to like post resources there for you guys to access. So it will be quite useful to be on there. Give me like another minute or two. Nice, guys. Okay, let's see. It seems like we're all on a roll here. So if you did this slightly easier question, I'll just get rid of that. Just remember I did change it here, but it was equal to 73, which term will be equal to 73 for B, not 74. But you're adding 3 each time, so it's an increasing function or an increasing relationship. Your general term was 3n plus 4. Term 50 was 154, and the 13th term was equal to 73. It looks like most of you tried the medium one though, so I'm going to go over there. I will let you screenshot both of them now in a second. Right, so if we have a look at the medium one, hopefully what you saw in the actual pattern was it was decreasing. We went from positive values to negative. So that means we're subtracting something each time. What your difference was -6. So your general term was -6n plus 11. The 34th term was -193, which I saw most of you got. And which term will be equal to -183? I'm going to try that again. -853. It is exactly as you guys have said, term 144. So really, really nicely done. Like I said, generally speaking, these we've been doing for a few years now. So this should be something we're comfortable with. But like I said, we now start to add stuff and add a whole new formula as of Monday when we start talking about arithmetic series. But we'll get there on Monday. Okay, so I'm just leaving it like that in case you want to screenshot both of them. It's always good to have an extra one to practice if need be. But we're going to move on to something a little juicier and then hopefully even more. Right. So let's have a look at example 2. Now, like I said, when we did quadratics, we often like to throw in variables and throw in algebra. Algebra is a part of your life throughout every section, geometry, trig, number patterns. It's just something we have to accept and something we need to be able to deal with. But because you've been doing algebra for so long, hopefully the comfort is there. But if it's not, we just keep practicing and it will get there, I promise. So we've been told that 4x plus 5, 10x minus 5 are the first 3 terms of an arithmetic sequence. Now, the second they tell you what it is, you now need to assign the characteristics. So this has a constant first difference. And that's going to be useful for me when I now need to solve for my unknown, to solve for x. Alrighty, so what we need to do here is we need to work out what our first differences are so that we can actually use that information of a constant first difference. Now, please remember when you're working out differences, so for example, this difference here, this is term 2 minus term 1. The next difference would be term 3 minus term 2. The next one, if we had the fourth term, would be term 4 minus term 3. That's how we work out our differences. So here we have 4x plus 5 minus term 1, which is x. Here we've got 10x minus 5 minus term 2, which is 4x plus 5. Now I'm putting that in brackets because there's multiple terms. I need to remember to distribute that negative into my bracket. Otherwise I'm not going to get the right answer. And because of, whoopsie, this bit of information that we know is true for any linear pattern, what we are able to say is that these two differences are equal. Okay, so this constant difference tells me that term 2 minus term 1 is exactly the same as term 3 minus term 2. Obviously, that could be anything. So term 5 minus term 4 is equal to term 4 minus term 3. The idea is that your constant differences are the same. They are equal to each other. And so we can set up this equation. And this is now where the algebra comes in. Now, obviously, guys, if you're comfortable with the algebra and you can simplify it sort of as you go, absolutely. So 4x minus that x is 3x plus 5. And then on the right, 10x, distribute the negative in. So it becomes 10x minus 4x is 6x. We're distributing the negative 1 to the positive 5. So it's minus 5, which is minus 10. And then this is just a linear equation that we can solve. 15 on the left, 3x on the right, because I'm subtracting 3x and adding 10. And so that means that x is equal to 15. Now the question said, determine the value of x. And then the second part of the question said, and hence the sequence. Now, really importantly here, guys, when I say the sequence, I'm not asking for the general term. The ways we ask for the general term are determine the general term, determine the nth term, determine the general formula, stuff like that. If I just say determine the sequence, quite literally all I want you to do is write down first term, semicolon, second term, semicolon, so on. And because we have x, we know that. So the first term was x, so it's 5. The second term was 4x plus 5, which would be 4 times 5, which is 20 plus 5. And our third term was 10x minus 5. So 10 times 5 is 50, minus 5 is 45. So that's my sequence. That's it. Okay, I'm not asking for a general formula or anything like that. When I say determine the sequence, I'm just asking you to write down the numbers. But what I quickly want you to try for me is to find the general term. So I'm going to add a question here. Determine the nth term. And I want you guys to try that. So I'll give you a minute or two. What is the nth term of this sequence? And remember, guys, I've shown you a couple ways that you can find this general term for linear or arithmetic sequences. Pick the one that works for you. Okay, we should never be telling you what to do if both or all the ways work. Some people do. That's fine. You do what you're most comfortable with. Nice, guys. Awesome. Tn is equal to 20n minus 15. And remember, if you want to check yourself, just substitute in. So sub in 1 for n, make sure you get 5. Sub in 2 for n, make sure you get 25, etc., etc. So just use substitution to check yourself if you're feeling a bit unsure. Right, so I'm going to wait there in case you need to screenshot this, but you're going to try one by yourselves now. And get into the fun ones. Okay, so this is the one I want you to try. We've got p, 2p, 2p plus 2, and 5p plus 3. I want the value of p, the sequence, so just be careful, I want the sequence, and then the value of the 49th term. So I want you guys to give it a try. Let's see what we come up with. You are welcome to put your answers in the chat. You are welcome to unmute yourself if you've got a question. You're welcome to put your questions on the chat or send me a message. Absolutely fine. Anything that you're comfortable with. I'm going to give you, let's say, 5 minutes to answer those 3, and then we'll have a look. Okay, guys, so remember, arithmetic sequence, constant first difference. That is the important feature that we're going to use. Guys, remember, don't panic if you get fractions. Sometimes fractions are part of sequences. You can always double check yourself through substitution and making sure you are actually getting a linear or an arithmetic pattern. Oh, guys, you're doing so nicely. Well done. Loving every single answer I'm getting here. Nice, guys. Amazing work. Okay, it seems like we're all on it, which is amazing. Yes. Does anyone need another minute or two? Just let me know in the chat with the thumbs up. You're good to get the answer, or a thumbs down. You still need a minute. No problem either way. Daniel, thank you. And take the non-responses, we're fine, but shout now if we're not. Okay, so let's see what we've got going on under here. Excuse me. So remember, it's an arithmetic, so you've got that constant first difference. And guys, you do it exactly the same as the last example. So we find our first differences. Because they are constant, because they're the same, we can make them equal to each other, and we can solve for p. So like I say, don't panic that p is a fraction. Once you've got that, you have to find the sequence anyways in b. So you sub it in and then you double check that you are adding the same value each time. In this case, what we're adding each time is 2.5. So it is arithmetic, it is linear, you're sorted. Question C is asking for the 29th term. Now that means that you do actually need to have the formula. So you have to first use your formula to go and be able to work out what the 49th term was. Now guys, if you choose to write, obviously like 2.5 is 5/2. If in your sequence you wrote 11.5 as 5.5, it's not the end of the world. Right, I just personally prefer fractions. That is what I always do. But as long as the number is correct in whatever format, you're absolutely fine. The reason I prefer fractions is sometimes we get confused between the semicolons separating the terms and the decimal. So that's why I prefer fractions. But really, it doesn't matter either way. And so we should have gotten that our 49th term was either 241/2 or 120.5. Again, either format, we're absolutely fine. Okay, so I'm going to leave it there. If anyone has any questions about any of the answers, please do let me know. Otherwise, we're going to move on to another arithmetic question that is a little bit different, but also one that we like to ask and one that I would advise being comfortable with. Kristen?
Hi, ma'am. I just had a question. For where it says like determine the sequence, will that always be a question following if they say like calculate the value or the variable? So then you know to sub it back in so that you get like the proper sequence.
So, excuse me, it isn't always. So sometimes they'll just go calculate the value of p and then skip to determine the 49th term or determine which term has this value. And then you will have to remember to substitute back. So it won't always necessarily be a question, but it's always useful to have it, like you say. So it's always useful to substitute back. I'm going to be honest, they don't actually often ask value of p or value of x and then determine the sequence. They usually go value of p and then say determine the 49th term. So then you have to remember to substitute, find the general formula, and then the 49th term. This is more just to get you into the habit of subbing back, get your sequence, and you can go from there.
Thank you, ma'am.
Sure. Nice, grade 12s. You are doing so amazingly tonight. Right, I want to skip that one. I want to go to this bad boy over here. This is one of my favorite questions in linear patterns because there are two ways to do it, two completely different ways to do it, and both are correct. One I find a lot easier than the other, but it is like completely how your brain works. What do you see works for you, and you work with what works for you. Right, I'm a very firm believer of that in maths. Okay, so what we have here is I don't even know what example. I think we're on example, I want to say 3, but it doesn't really matter. In an arithmetic sequence, T10, so the value of term 10 is equal to 34, and T4 is equal to 10. So the value of term 4 is 10. Determine the value of term 50. Now the problem with this is I've got term 4 and I've got term 10. I have nothing in between. I've got nothing before that. How on earth am I going to get to term 50? We know that because it's arithmetic, we have a constant difference. And so one of the ways to approach this question is to use that fact. And this is why I keep saying to you, know what your pattern is, know what defines your pattern, because that is useful to you. So I have no idea what term 1 is, term 2 or term 3 is, but I know that term 4 is 10. I don't know term 5, 6, 7, 8, or 9, but I know that term 10 is 34. I then need to get to term 50, but we'll get there. So I like to just set up this almost like incomplete sequence, just to see what I'm working with. And this is helpful for me to visualize the fact that because this is a linear pattern, what I'm actually doing is I'm adding that constant difference each time. So from term 4 all the way to term 10, I'm just adding a whole bunch of differences. That was a weird situation I just did there. Let's try that again. I'm just adding a whole bunch of differences to get from term 4 to term 10. And this is quite useful for me because if we go back to algebra, if I'm adding the same thing each time, I would just say D times whatever. So if I'm adding 7 differences, I would just have 7D. If I'm adding 3 differences, I would have 3D. Algebra comes into play, like I was saying, everywhere. So this is useful for us. So what I know is that if I take my value of term 4, which is 10, and I add 1, 2, 3, 4, 5, 6, 7 differences. No, I can't count. 1, 2, 3, 4, 5, 6 differences. I will end up at term 10, which has a value of 34. So I've just set up an equation for myself to work out the differences. 60 is equal to 24. And so the difference is equal to 4. Now that's great because this is super useful for me. Knowing the difference means that I can go and start substituting into my formula that we were given earlier, because now I know what the difference is. And I can actually now use it to work backwards to term 1. If I'm going to go backwards, I would now need to subtract 4 from 10 to get 6, and subtract 4 to get 2, and so on. And I'm able to then get term 1. And all of this is super useful now because now it's easy. I can go find term 50. To find term 50, I'm just going to sub in. So I'm going to go under here. So term 50 is equal to A, which we've just worked out to be -2, plus 50 minus 1 times the difference, which we worked out as 4. That's it. We sub that into our calculator, and we get that term 50 is equal to 194. So when you get a question like this, and excuse me, we spoke about this as well when we did quadratics, use the characteristics of your sequence. Use the constant first difference. Use the constant second difference. We did an example like that on Monday. Those characteristics are made explicit to us because they are helpful. So me using this constant difference idea makes this calculation a lot easier. There are other ways to do it. I'm not saying this is the only way, but this is probably the easiest way that you could do it. So out of interest, if you guys look at this, does anyone or can anyone think of another way that they might be able to deal with this? Because I'll be honest, this method would not have been my first thought. Nice, that's yeah, simultaneously, guys. We could solve this simultaneously. Now, some people love simultaneous equations. Some people hate them. I love simultaneous equations. So I think that's why in my mind, I would just go straight to simultaneous. So I enjoy simultaneous. But you were given T10 is equal to 34 and T4 is equal to 10. You have been given a value of n and a value of Tn. You can sub in. Okay, so what you have is, my brain's just decided to stop working, is Tn is equal to A plus N minus 1D, and we can substitute in to get two equations. So equation 1 would be if I substitute in T10. So 34 is equal to A plus N is now 10 minus 1D. So 34 is equal to A plus 9D. And our second equation is if we sub in the value of term 4. 10 is equal to A plus N, oh golly, Miss Molly, N, which is 4 minus 1D. So 10 is equal to A plus 3D. You now have two equations that you can solve simultaneously. Now, there's nothing wrong with that. Like I say, that's probably what I would do because I enjoy simultaneous equations. It's a process I would enjoy, but it's not the only way. If you go and solve this simultaneously, you end up with the same value of D, the same value of A, you're going to get the same answer. So again, grade 12s, don't feel like you have to do it a certain way. If you find a method that works, that is mathematically correct, use it. There's nothing wrong with doing it differently to your teacher, to your friend. As long as it is mathematically correct, you are good. Alrighty, so I'm going to let you take a screenshot of this. And then we've got a few more minutes, and so we should be able to fit in one more. And this is quite a nice question. This is actually also a past paper question. So this came straight from a past paper. It was one of the ways that they tested arithmetic sequences in a grade 12 exam. So nice to also see how these things are tested. Right, before I move, does anyone have any questions? Anything they're not too sure about? Okay, nice, grade 12s. Right, so let's have a look at one last question before we wrap up for our Wednesday. So we're given the arithmetic sequence -5, P, Q, 7, and so on. And all I'm going to ask to do is determine the values of P and Q. Again, goes back to what I was saying. What is the defining characteristic of a linear or arithmetic sequence? It is the fact that it has a constant difference. All right, so the first thing that I will always do, regardless of what I'm working with, is I will always work out those differences. If I can see it's geometric, which we'll get to, I'll work out the ratios. But here I'm going to work out differences because I've been told it's arithmetic. So this is P minus 5. If you want to say P plus 5, that's fine. This is Q minus P. And this is 7 minus Q. Okay, so I've worked out my differences. What's such a problem? Now, because we have 3 first differences here, and because we have a P and a Q that we need to solve, we are going to have to do this essentially simultaneously. There's no other way for me to work out 2 unknowns in this case without using simultaneous equations. Sorry, guys, there's something in there. So the first equation is going to deal with equating the first 2 differences. And the second equation is going to deal with equating the second and the third. They're all equal to each other, right? So technically you can make any of them equal. It doesn't really matter. But it just, it's easier to group 1 and 2, 2 and 3. So if we set up the first equation, we've got P plus 5 is equal to Q minus P. And if we set up the second equation, we've got Q minus P is equal to 7 minus Q. And now we can solve simultaneously. It doesn't really matter where you choose to go. I'm going to start sorting out equation 1 first. So I'm going to bring the P over, leaving me with 2P plus 5 is equal to Q. All right. And then if I go over to equation 2, I am going to essentially do the same thing. So I'm going to bring that negative Q over. 2Q is equal to 7 plus P or P plus 7. It's up to you. Now, what you have done in equation 1 is you have worked out a value for Q. You know what Q is equal to in terms of P, which means that that can be substituted straight into your second equation. So now we've got 2 times 2P plus 5 is equal to 7 plus P. And now we only have P's in our equation, which means that we can solve for P. So this is a nice linear equation. This would be 4P plus 10 is equal to 7 plus P. And so 3P is equal to -3, which makes P equal to -1. Oops, let's do that a bit neater. So that was one of the values I was asked to find. Remember, in simultaneous, once you have one of the variables, all you now need to do is take that variable and substitute it back into either one of the equations. It doesn't matter. I'm going to choose this highlighted equation because it's already got Q isolated. So I'm automatically going to get my value for Q. So that means that 2 times -1 plus 5 is equal to Q. And so that means -2 plus 5 is Q, which means Q is equal to 3. And then you've got the value. Now back to Kirsten's question. If I had now asked you in the next question, determine the general term or determine the nth term, you would need to take those values and substitute them back in to get your original sequence or your original pattern in order to go and answer that question. So it is always useful if there are follow-on questions to substitute your values back in so that you know the numerical pattern that you're working with, and you can then go from there. Okay, but sometimes simultaneous is unavoidable, especially when you can't sort of work out how many differences you're adding or subtracting to it. And especially when you have, like here, 2 unknowns in the sequence. So we had P and Q in our sequence that we didn't know. And so sometimes simultaneous is unavoidable. But again, use the characteristics of your linear pattern, the constant first difference, to work it out.